So this question is about asking a class of children, how many computer games do you have at home? And then all the class filled in on a piece of paper how many games they had at home. And we can see that there are a lot of different numbers here. So let's see how many kids said that they had 0 computer games. And to make sure that we don't miss on a number here, we actually just put a little red line through them here. How many children had 0 computer games at home? 1, 2, 3, 4, 5. I get it to 5 children said that they had absolutely no computer games at home. Then we look at how many children said that they had 1 computer game at home. 1, 2 ones. So there's only 2 children that had 1 computer game at home. 2 computer games. How many children had 2? Just cancel all the 2's away. We're looking for 2's. 1 there. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 children had 2 computer games. Now we're looking for 3's. 1, 2, 3, 4, 5, 6, 7, 8. 8 children had 3 computer games. What about 4 then? 1 4 there, another there, 2, 3. 3 children had 4 computer games. Look for our 5's. How many children had 5? 1, 2, 3 children had 5. 6 computer games there. Now we're sort of running out of kids. Most of the kids have gone now. But there's 2 children who had 6 computer games. There was 1 child who had 7 computer games. And there was 1 child who had 8 computer games. Okay? So now we've actually finished with this data. We don't actually need it anymore because now it's all in our frequency table. So we can have a quick check here that make sure that all the numbers are crossed out so that you haven't forgotten anyone. So you do it in a structured and organized way, turn this big jumble of numbers into, put it into a frequency table that we now can use quite easily to calculate the mean, median and mode. So we remove these numbers now. How many children have we asked? Well, we can find out the number of children that we asked in this survey by just adding up all the numbers that we have here. 5 and plus 6 is 11. 8 plus 2 is 10. 11 plus 10 is 21. 21 plus 3 and 3 plus 6 is 27. 27 plus 2, 29. 30, 31. Okay, we had 1 too many 2 in my table, so we'll just remove that. It should have actually been 5 lots of 2. 5 lots of 2's. So again, we try and find multiples of 10 to add up, because it's a lot easier to add up with multiples of 10. We've got an 8 and a 2 here that's going to give us 10. We've got 2 5's there, which is going to give us another 10. We're now at 20. And then we've got 3 plus 3 and 4 there. That'll be 6 plus 4 giving us 10. So we've asked 30 children. So the number of children that we've asked in our survey is 30. So we have that data here. Number of children surveyed equals 30. And to calculate the mean of a number, the mean is the total of all the computer games. In this case, we're all adding computer games, seeing how many computer games they've got, divided by the number of children. So it's always what you're looking at, the total of all the computer games that all the children have, divided by the number of children that we've questioned. And we know that we've questioned 30 children here in this survey. So we could find out the mean in a very long-winded way by adding 0 plus 0 plus 0 plus 0 plus 0. So we've got the 5 zeros, and then we've got 2 lots of 1, and then we've got 5 lots of 2. But that takes a very long time. And we could carry on doing that until we got down to 1 lot of 8 at the end. And much easier, and then dividing it all of these numbers that we added up, we'd finish off here with an 8. We'd divide it by our number of children, 30. An easier way of doing this is using our frequency table to calculate the mean instead in using our table. And it saves a lot of time. The reason that it saves a lot of time is we multiply that 5 children had 0 computer games. So instead of adding 0 5 times, we can just say 0 times 5. We had 2 children that had 1 computer game. So we add to that 2 children had 1 computer game. 2 times 1. We then add that there was 5 children who had 2 computer games. So times the children by the number of computer games, and then just add here in between. Then we have 3 times 8 plus 4 times 3 plus 5 times 3. So you've still got a lot of numbers, but you don't have to add them all up. You can do some quick multiplication first. 6 times 2 plus 7 plus 8. All of those numbers divided by the number of children that we have will give us the mean, which will be 30. Right, let's turn that into a long string of numbers then. 0, and I'm going to write it up here instead in blue. The mean will end up being 0 times 5 is 0, so we don't need to bother about that anymore. 2 1s are 2, plus 5 2s, 10, plus 3 8s, 8, 16, 24, plus 4 3s, 12, plus 5 3s, 15, plus 6 2s, 12, plus 7 plus 8 is 15. So we've now got one much shorter string of numbers, and we divide all of that by 30. We can see directly here, if we look, 15 plus 15, that's going to give us 30. Here we have 24 plus another 24, which will give us 48, plus a 2 there, that will give us 50. So we've got 50 plus 30 now, plus 50 plus 30 will give us 80, plus 10 there will give us 90. So our mean is going to be the total of all our top numbers, 90, divided by 30. 90 divided by 30 is the same as 9 divided by 3, which is 3. So the mean number of all of these numbers that we found out, the average number of computer games that the pupils in this classroom had, was 3. Now we'd like to find out what the median is. Well, to find out what the median is, we actually just put the numbers all in alphabetical order. Numerical order, sorry. Keep saying that. We put all of the numbers in numerical order, and that means we start with the smallest number. And we have to include our zeros. So when we're working out the median, it basically just means the middle number in a long string of numbers. So we have to include the zeros because they were there in our survey. There were a lot of children who had 0 video games. So we start by making a long, long string of numbers, 5 zeros, there was 2 1s, there was 5 2s, so we just put them all back, but now they're all in order. 5 lots of 2s, there was 8 lot of 3s. 2, 3, 4, 5, 6, 7, 8, and it doesn't matter that we're going on a different row. There was only 3 lots of 4. There was 3 lots of 5. There was 2 lots of 6. There was 1 7, and there was 1 8. Now, to find the median, we're just looking for the middle number, so we cancel the largest number with the smallest number, and then we carry on doing that until we get into the middle. So, largest against smallest, and we just keep on doing that the whole time. So the 5 cancels against that 0, this 5 against the 1. We're just trying to find the middle number. And we take 1 from the top line, and 1 from the end of our string of numbers, and 1 from the beginning the whole time. And then we can see we've got 2 numbers here in the middle, but they're both 3's. So the average of these 2 numbers, 3 plus 3 divided by 2, will be 3 anyway. So the median of this investigation is also 3. Exactly the same as our average was. And the next question is, which one is the mode then? Well, the mode of our numbers is just which one happens to occur most frequently. The one that occurs most often. And again, our frequency table helps us a lot here. We just look down the frequency table and say, which one has the biggest number? Here's an 8. 8 is bigger than anything I've got there. So, how many computer games was the most common? 3 computer games was the most common, because there was 8 children who had 3 computer games. So, our mode number, or in Swedish, typvärde, for this actual investigation is also 3. And it's okay that all of these 3 numbers ended up having exactly the same number. They don't necessarily have to, but they can end up that the mean, the median, and the mode all have exactly the same number, and that's fine. Okay, that's how we